Okay, welcome to my YouTube channel. And in this video we're going to look at motion under mechanics, physics, motion. So quickly, let's define some specific terms which are used in motion. So definition of motion: motion is the change of position of an object in a given direction. So motion is the change of position of an object in a given direction. What they're simply saying here, motion, the change of position in a given direction. Motion can change its direction, and the object can change its position in a specific direction. So we call it motion. For example, you're moving a car in the north direction, then you change position, you start going to the east. That's what we call it motion. We have given the direction which is east, and the object changes position from north to east. So types of motions. Now let's look at types of motions. Type of motions we have: number one, linear motion. This is the movement of an object along a straight line or path, e.g. a car traveling along a straight road. That's what we call linear motion, coming from the word line. The linear is coming from the word line. So if you put that line in motion, we call it linear motion. Object moving in a straight path or a straight line. That's what we call linear motion. Then you have circular motion, or in other words, rotational motion. This is the movement in a circle about the center of an axis. This is the movement in a circle about the center of an axis, e.g. spinning a wheel or rotating a fan. It's going around, but it's in the same position. It's on the same axis. When I say that it's on the same axis, it simply means that it's fixed in one position. Okay, the third one we have oscillatory motion. This is a movement where an object moves to and from about a fixed position, e.g. swinging the bulb or the pendulum. We look at the pendulum. I'm sure you understand this motion after you have watched that video of the pendulum. So if you want to understand this motion, you have to go back to the video of the pendulum. That's why you can understand this motion. Okay, so now we go to number 4. Number 4 here, we have random motion. This is a movement of an object in a disorderly manner. In the case of gaseous particles, they're just moving anywhere about, up and down. They don't have direction. Examples like Brownian motion. Yeah, it's a good example of random motion. So now, in this video, we're going to look at specifically linear motion. Under linear motion, we're going to look at distance and displacement in this video. In the next video, we'll look at speed alone, and the other video, velocity alone. Just like that. So without any further ado, let's go to the main purpose of this video, which is distance and displacement. Okay, so distance is measured in is symbol is S. It's measured in meters, and definition of distance is a length between 2 or more points. So distance is the length between 2 or more points. Like for example, my arrow which I'm using here to point, you have a point which is blue here, and the point which is green. So the distance from point where this is blue, where the arrow is blue, to the point where the arrow is green, that space between, we call it distance. That's what this statement means here. So it can also be defined as the actual path traveled by an object from its initial position to the final position. Yeah, you can also define distance in other ways using that statement. Final, initial meaning the starting point, final meaning the resting place of that object. Other units for distance, we have millimeters, centimeters, kilometers, and so on and so forth. Now the relationship of converting these SI units is that 10 millimeters is equals to 1 centimeter, 100 centimeters is equals to 1 meter, 1000 meters is equals to 1 kilometer. So each time my person says, no, my distance from my place to my school is 2 kilometers, what I'm saying that actually there is 2 1,000 meters between their home and their school. So for example, here, if you want, you can convert 20 centimeters into meters. It's possible. We can do that. How? So see how you do it. So we have solution here. We know that for a fact that 100 centimeters equals what? 1 meters, Then we know that 30 meters, we have been given what? 30 centimeters in our question there. But we don't know the meters. You should convert 30 centimeters into what? Meters. So what do? We just cross multiply. Using this principle, which the fact which we know that 100 centimeters equals to 1 meter, just cross multiply here. Say okay, 100 times x, 1 times 30, and that's where this on top is coming from. Then the x is just 100 times x, then you divide by 100 so that you make x a subject of a formula. After doing that, you're going to have 30 on top, of course, here. Then you divide it by 100. After dividing by 100, you're going to get this answer in meters. So in short, 30 centimeters is equals to 0.3 meters. Hope it's clear there. Okay. We have an exercise right here. So I want you to attempt this question A, B, C, and D. After you have attempted this question, just comment the answer. Leave a comment on this video. Then I'll check your answer. Then if it's correct, I'll give you a thumbs up. If it's wrong, I'll reply with a correct explanation on I'll explain to you where you went wrong, or I'll guide you again. So now let's look at displacement. Symbol S, displacement is measured. There's a symbol S, and this SI unit is what? Meters. Same. Children. Okay, so sorry for disturbing that. Definition is what? Displacement is the distance traveled in a specific direction. Definition: displacement is a distance traveled in a specific direction. That's what we call it, displacement. For example, the displacement between point A and point B is a straight line here, this one. That's what we call it, displacement. Not this one. This one, distance. Distance has not a specific direction. Wow. Displacement has what? A specific direction. So here, let's look at similarity between distance and the displacement. The SI unit for both distance and displacement is meter. That's one different. Also one similarity between distance and the displacement. The similarity is that they are both measured in what? In meters. And the differences between distance and displacement. Number one, distance is a scalar quantity. It's a scalar quantity, while displacement is a vector quantity. Why have you said so? Because we know that a scalar quantity only has what? Direction. It only has what? Magnitude, but it has no what? Direction. While a vector quantity, we know that it has both magnitude and what? Direction. So distance is a length between 2 points. Wow, displacement is a distance traveled in a specific direction. These are the two differences between displacement and the distance. Also, this question do come in the exam. In the exam, so you need to pay attention to them. So look at the example. A car moves 15 kilometers to the east and 13 kilometers to the north. It starts off 15 kilometers, again it moves to the north 13 kilometers. The question is asking us to find the distance covered by the car. So we know that distance is just the total length between 2 points. Doesn't matter in any direction, just the total distance. So just simply add the 15 plus 15 there to give us here you have 8 there too. So we're going to have 28 kilometers, which is here. Then the next question B is asking us to find the displacement of the car. Displacement of the car is equal to east and north. just 15 kilometers east and 13 kilometers north. Why haven't we done any calculations here? It's because that, remember, when defining displacement, we said that displacement does what? Direction and magnitude. This is the magnitude and this is the direction, unless if they were in the same direction. So you can do anything or subtract or add. I haven't done any math here because we are all in different directions. That's why. Then we go to example number 2. The circumference of a roundabout is 50 meters and the car turns it once. Okay. I've been asked to find number 1 question there. So I've been asked to find what? The distance covered by the car. We know that the circumference of a roundabout is what? 50 meters wrong. So the distance would be what? 50 meters. That's how you find the distance is straight forward. Then the question is asking us to find what? The question B is saying find the displacement of the car. So displacement of the car is 0 because the car comes back to the certain point. Remember, if you're going, it's like if you want to understand this displacement much better, think of it as a number line, in a form of what? A number line. What I'm saying is that a number line, we know that when you're going to the right side, numbers are increasing or they are positive numbers, isn't it? And if you're going back, the numbers are what? Reducing. So if you have positive 2, if you went positive 2 on the right side, then you went back again 2 steps backward, it simply means that you have subtracted 2 from 2, which is what? 0. That's how you understand the displacement. Think of it as in a number line. If an object starts from A, goes around and around, it doesn't matter how many times, as long as it returns back to its starting point, the displacement will always be 0. Why? Principle of the number line. You have a positive and a negative, because then the numbers are same when you subtract them to give you what? Is 0. That's why. Okay. An example: a boy walks forward 25 meters and backward 15 meters. Like I said, you need to understand displacement in the form of a number line. So find the distance covered by the boy. Then the distance, you just add it. There's no need to put it in the number line. You just add. Then you get what? 40. That's the distance the boy walked. But for displacement, if you think of it as a number line, you notice that the boy walks what? It says forward. Forward is what? On the right hand side. And then on the right hand side, numbers are what? Are positive. Let me see if I can draw the number line here. Okay. You have the number line here. This one. There you have 0. You have 0 there. You have 1, 2, 3. This is a positive side. You have positive 3. Let me see do this. You have 1, 2, and 3 there. That isn't properly. Just do 2 when you have this and this. And just draw my lines properly. Okay, just like that. Then here you have negative 1, negative 1. You're going to have negative 2, you're going to have what? Negative 2. Like I was saying, you need to know that if you want to understand displacement, you need to think of it as what? Any number line. And I said that the number line, when you're going to the right side, the numbers are positive, and when you're going to the left side, numbers are what? Are negative. So here, they have told that the boy started from 0. For example, 0. Let's say here, instead of using, let's say, let me give an example, then we'll go back to the same question again. Let's say the boy moved 2 kilometers to the forward, walks forward 2 meters here, which means the boy started from here, then he walked up to here. Then the boy again walked backwards again 2. You understand? 2 meters again, which means you go back, you still end up at what is the starting point. Hence, our displacement will be what? Will be 0. That's how displacement works. Okay. Thank you for watching my YouTube channel. Don't forget to, before I go, I have to explain this. And using this principle I've said here, you apply it on this question here. You notice that we have subtracted 25 from 15. Why? Because the boy worked 25 forward on the positive side, then went back 15. So subtract and give us 10 meters forward. You still end up on the positive part. Why? Because the distance moved forward is greater than the distance moved backwards. That's why the number is still positive here. It will be on the positive side either ways. That's what it means. Thank you for watching my YouTube channel. Don't forget to like, subscribe, and share as well.